Or Chapter 2 summary. Now that you have completed the chapter, let's review the new terms, concept, the ideas you've learned. You should have a thorough understanding of the principle or before moving on to Chapter 3. Induction field is contained by the electric field and the magnetic field, but localized near the antenna of the electric field and the magnetic field and the inductive field with 90 degrees out phase with each other. Radiation field, they contain the electric field and the magnetic field, but they are propagated with the antenna into the space to form an electromagnetic wave. Electric magnetic field, the radiation field phase with each other. Harmonic frequency, any frequency, the whole number of the multiple small basic frequency. For example, the radio wave transmitted with the frequency of 3,000 hertz can have the second harmonic with the 6,000 hertz, third harmonic with the 9,000 hertz, and transmitted at the same time. Vertically polarized antenna transmits the electromagnetic wave through the electric field perpendicular to the Earth's surface. Horizontally polarized antenna transmits the radio with the electrical field parallel to the Earth's surface. Wavefront is a small section spanning sphere of the radiated energy, particularly the direction of the travel of the antenna. Radio waves, electromagnetic wave that can be reflected, retracted, atmosphere like light, and heat waves. Reflected radio waves are waves that have been reflected with the surface and are 180 degrees out of the phase of the initial wave. Earth's surface of reflected radio waves. The Earth's atmosphere is divided into three separate layers: the troposphere, the stratosphere, the ionosphere. The troposphere is a region of the atmosphere virtually where the weather phenomena that play for the region where the radio frequency energy is greatly affected. Stratosphere with a constant temperature has little effect with the radio wave. The ionosphere is the four clouded layers that are electrically charged ions with aiding long distance communication. Ground waves and sky waves are two basic types of radio wave that transmit energy with the transmitting antenna to receive the antenna. Ground waves are composed of the two separate components, the surface wave and the space wave. The surface waves are travel along contour of the Earth of diffraction. Space waves can travel through the air directly, receive the antenna, and can be reflected with the surface of the Earth. Skyways often isonic waves radiate with the upward direction, return to the Earth sometime in the distance will be covered with a refraction. Natural horizon line of sight with the horizon, radio horizon, 1/3 with the natural horizon. Ionosphere with the consists of several layers. Ions form with a region process called ionization. Ionization is a process of knocking electrons free with the parent atom, the upsetting of electrical neutrality. Recombination opposite of the ionization. Free ionization combined with the positive ions cover the positive ion to their original natural atom state. The D layer, lowest region of the atmosphere, refracts the signal of the low frequency back to the Earth. E layer presented during daylight hours refracts signal of 20 megahertz or back to the Earth, with the communication up to 1,500 miles. The F layer divided in F1 and F2 during the daylight day combined night to form one layer. The layers were responsible for high frequency, low range transmission. Critical frequency, the maximum frequency radio wave can be transmitted vertically and still be refracted back to Earth. Critical angle, the maximum minimum angle of the radio wave can be transmitted and still refracted back to Earth. Skip distance, the distance between the transmitter point with the sky wave at the first return to the Earth. Skip zone is the zone of silence between the point where the ground wave becomes the 2 week for the reception point where the sky will first return to the Earth. Fading is called the variation. Signal strength is such as the absorption of the radio frequency energy with ionization. Multiple path fading can occur with the transmission. Signal divides and takes more than one path to do the receiver. Then some of the signals arrive out of phase and then result of the weakening or fading signal. Such transmission law with the effect of the radio wave propagation, ionosphere with absorption of ground reflection, free space law with electromagnetic interference with the EMI. Both natural and man-made interfere with radio communications. Maximal usable frequency, highest frequency that can be used for the communication between the two locations, given the angle, the incident, of the time of the delay. Lowest usable frequency, lowest frequency that can be used for the communication between two locations. Optimum working frequency, or FOT, the most frequent operating frequency that one of that can be related with heavy to high fewest problems. Precipitation attenuation can be coupled with rain, fog, snow, hail, and can affect the overall communication considerably. Temperature inversion cover the channels or ducts cool air to form between the layers of the warm air, which cover the radio waves to be travel far beyond the normal line of sight of distance. Tropospheric propagation uses the guiding principle to achieve beyond the line of sight radio communication with the troposphere. And that was Chapter 2 summary.